I see a lot of familiar faces, so I won't do any more explanation. This has been a pet peeve topic of mine for the last 4 years, and it fits into the digital transformation topic. Particularly, 4 years I worked in the Dow Chemical Company. 25 of those years was on the manufacturing floor in various capacities with intimate relationships with the operators, the users of these particular standard operating procedures. So my thought process is how would digital transformation of industrial procedures improve what we already have? Okay, so I'm going to take you on a journey. It's actually a family journey. You'll find it interesting. Industry 4.0, 1, 2, 3, 4. Everybody's probably seen the slides. So when I researched this topic, I thought of my family. Literally the generation from my great-grandfather, father, myself, my daughter, and now my grandson, okay, and how this technology has evolved with my particular family, who, by the way, have a combined contribution to the Dow Chemical Company of 75 years. So we're in the third generation. So let's take this generational walk, okay? In the first industrial revolution, fundamentally my great-grandfather, trades trained as a master mechanic in machinery during this time frame, right around 1900, emigrated from Stuttgart, Germany to Canada, and specifically to work in the mills, the sawmills. And so he was responsible for the keeping any kind of rotating equipment or machinery operational. Okay, and so he was taught by another person. I mean, the first industrial revolution involving steam, electricity, petroleum-driven machines, okay, he was taught how to use those motive forces and the mechanics to make the machines run. And he was taught essentially by a tribal knowledge. Some individual taught him, not as a formal trades training, but informal trades training. And he knew how to do this hands-on, so it was informal instruction that he didn't write down, he put it in his head. Okay, so the next generation of my family, okay, fundamentally, he immigrated across the Detroit River to Detroit, okay? And fundamentally, in the 1920s, what happened in Detroit, Michigan? It's called Henry Ford and Mass Assembly, okay? In this case, automobiles. So he was, grandfather was actively involved in that. And the key concepts around that was to actually division of labor, mass assembly, and the individuals were trained on very specific tasks to accomplish the overall assembly. Typically, what you had was, does this pointer work? Nope, wrong thing to do. The arrow goes the wrong direction. You got it? Typically, there was a lead man. Okay, and the lead man would train the people on the various assembly line, and their work instruction was like crib notes or a little black book that they'd have in their pocket, what have you. And they were trained by people who, we're really getting off here. Trained by people, this is the second industrial revolution. They were trained by individuals, and that tribal knowledge was somewhat more systematized. It might be documented on paper, but there was no standardization of it. It was very highly individualized, and so you get variable performance on the assembly lines. So we're in the second generation. Okay, so this takes us up to a timeline of about World War II. Okay, and in World War II, the auto factories were converted to military. My grandfather worked in the summertime as a farmer. In the wintertime, he built Thompson machine guns in an automotive plant. The war ends, and now fundamentally, these same skills are then translated back to the automotive industry, and on we go. Now the next generation, fundamentally, is the introduction of computers in the assembly lines. We call them tape machines. Why were they called tape machines? Anybody? paper tape. It was the first introduction of PLCs. And you'd have these machines on a monorail, okay, that would do drilling and milling operations, and they were controlled by PLCs. Okay, so again, there were still manual tasks that had to be performed at those stations, but fundamentally automation was introduced. And my father was the guy who programmed the tape machines, okay, to make these machines run. Now, one of the problems that we experienced in the auto industry was fundamentally its coexistence of the human being and the machines. Okay, obviously, process safety even back then was number one issue that needed to be addressed. But there was a lot of setup things that had to be done. There were a lot of troubleshooting things that had to be done. If everything was steady state, the PLCs would run the machines. But things did break down. And so there were a lot of more formalized instructions that were provided. But again, these instructions were asynchronous from what was going on with the PLCs. So that takes us up until the timeline, roughly up until the 70s, okay? 70s and 80s, when more advanced control was introduced, and yours truly went to the university, okay? Into my generation. In my generation, in 40 years of that, what did we gravitate from? 1 year before graduation, I was still using a circular slide rule that I carried, okay? When I graduated, I purchased my first Hewlett-Packard HP 35 hand calculator. I thought I was a god at that particular point in time. Okay, but we're still dealing with the introduction of computers, and over that 40 years period of time, fundamentally, we've had huge advances in automation, okay? But there's still these manual procedures, probably in crib sheets or whether the people are hanging on to do asynchronous activities, startup, shutdown, maintenance type activities, and they're not coordinated with the advanced computers that are now running these processes. After 4 years at the University of Michigan, I graduated and joined the Dow Chemical Company. 40 years later, back one. 40 years later, this arrives. Industry 4.0. Now, I'm about to leave Dow, but I'm still curious as to how this digital transformation is going to impact my old company as well as other companies that I consult for through ARC. And I noticed one thing. A lot of technology like virtualization, virtual I/O, augmented reality, digital threads, what have you, in the cloud. All this technology is becoming available, but the fundamental question is, how can I take this technology and improve upon what we've done in the third generation, the third industrial revolution? Because fundamentally, we still have a disconnect between manual procedures and full automation. There's still a lot of activity out there. There's still a lot of valves. I work in the chemical process industry. If you look at a P&ID, roughly about 35% has some level of automation on it, between 30 and 35%. What's the rest of those valves for, or those motors out there? It's for startup, shutdown, maintenance, and non-continuous activities that happen sometimes on a routine basis, like, for instance, clean in place. Cleaning the screens on the suction side of a pump, okay, is a good example. Happens routinely. So I'm asking myself this fundamental question is, will the Industry 4.0 solutions for digital work instruction become the next breakthrough for human-machine performance? That's the fundamental question. So I started looking at for the ARC research report, and you can have copies of it. I came up with over 24 potential solutions for digital transformation of industrial procedures. From simply Microsoft Word to much more advanced procedural engines, and lots of technology out there. The report articulates a number of technologies available. But I asked the fundamental question, are we really solving the problem of operator performance? And more importantly, the question to be asked is, with all the technologies that's available out there, with all of the operating discipline, behavioral modification type solutions, to invoke on our operations staff. Why are they not following procedures? It's happening out there a lot. Both academic institutes and industry associations have actually studied this problem. The research is available out there. This is kind of a summation of the top categories. And some things that stick out fundamentally is there's 3 stages of a procedure. It needs to be authored, and the content needs to be accurate and version controlled so it can be dispersed properly. The next thing is, in this new world, the procedure needs to be portable. Books on the shelf are no longer legitimate anymore. A lot of procedures are documents sitting on a shelf and the operator is not using it because it's not useful in the field of action where they're working. So accessibility is the third item that I've come up with is disconnects, and it's the asynchronous behavior between executing a procedure manually and all the automation that's happening around it. Things are happening. And I will say that one of the motivations for me looking into this was a death that occurred in our company in Texas City involving that procedure I just mentioned about cleaning the screen on the suction side of a pump. This is what we're trying to prevent, okay? So is there some, he'd been doing this job for 25 years. This screen change was every shift. I mean, the number of times this procedure was executed is a phenomenal number. Could it be an accident? Is there something we could have done to prevent it? I will tell you, there was asynchronous behavior occurring between the execution of that procedure and a very advanced control system that was running around it. Is there something we could do in the digitization of industrial procedures to prevent such an occurrence? So I did a classical, you can't read this, it's a failure modes and effects analysis of severity, frequency of occurrence, and detectability, and you look at, from top to bottom, the index of possibilities. And during the top one, risk is working on, in that particular case, working on the wrong piece of equipment at the wrong time, executing the procedure in the wrong sequence of activities. There was nothing to prevent him from doing these manual actions asynchronous from the control process, and fundamentally, he was exposed and unfortunately he died. So what can we do about this? I think there is a way. I think there is technology available both from the 3rd Industrial Revolution and technology available in the 4th Industrial Revolution. If we combined our knowledge and the new technology that are available, we can provide an integrated solution that provides a higher level of reliability of human performance. So you got to look at, to solve the problem, you have to understand what the defects are, why are operators not using procedures, okay, and what can we do to prevent that or ensure that it does happen? We need a functional specification that defines from the eyes of the end user how the procedure needs to be executed before you can digitize it. You got to define it before you can digitize it. It's not simply taking a Microsoft Word document and putting it on a mobile device. That's not digitization, that's just electronic transfer and display, okay? Last but not least, or third, you need to be able to translate it or digitize it such that it runs in the real-time world. And last but not least, you have to provide this integration between the automation that you have out there and make sure that the manual activities are synchronized with the automated activities. This is it in a nutshell. Now, this report is available from ARC. Everybody who's attended can get a copy of it. You can contact your ARC representative or myself and get this study. It literally goes through all 4 industrial revolution stages and looks at where we are technologically today and how we could potentially move forward in the future. So let's have some presenters up here who will show going through this particular journey. And the second presenter is Sandy Curry, and what he's going to describe for you is how do you actually define? How do you define the industrial procedure that is an integrated solution between automation and manual activities? So Sandy, you're up next.